This is going to be a quick lesson on solving square root and other radical equations. So we're just going to model a bunch of examples here and clarify a few things after about 2 examples. So this first one is asking us to solve this equation here. We have 3 plus the square root of 2x minus 3 equals 8. First thing you want to do is isolate your radical, and the way we're going to isolate the radical is we're going to subtract 3 from both sides. When we subtract 3 from this side, it's gone. When we subtract 3 from this side, we have, instead of an 8, a 5. Then we have the 2x minus 3 still in the radical right over there. Next, we want to solve for x. And right now, x is inside of this square root. How do you get rid of a square root? You have to apply the inverse operation. What's the inverse of a square root? The inverse of a square root is to square something. So I'm going to square both sides. Now you have to keep in mind, when we square both sides, if this were a 5 or a negative 5, they both would end up being 25. So we're going to see in a few examples that this positive negative concept here is going to play some games with some of our answers. So we're going to bring that up in a few examples. The square root and the square, that leaves us with just 2x minus 3 right here. And then 5 squared is 25. Add 3, we have 2x equals 28. Divide by 2, x is equal to 14. If you want to go back and check, 2 times 14, 28 minus 3, 25. Square root of 25 is 5. 5 plus 3 is 8. Definitely works. Good. We're on to the next example. Alright, sorry, it's a little hard to see that one. Alright, so that was example 1. We're on to example 2. Example 2, similar idea, but this time we have a 0 on this side, no big deal. So we're going to bring the 5 to the other side with addition. We have the square root of 4x plus 1 will equal positive 5. Square both sides again. Square both sides, and we get 4x plus 1, just the radicand. Now remember, we're squaring because it's a square root. If it were a cube root, we would cube both sides. If it were a fifth root, we would raise both sides to the 5th power. So you need to do the inverse operation, all right? That's 25. Subtract 1, 4x is 24, and divide by 4, x equals 6. You could check it. I promise you it works. We're good to go. That's all. Next example, or actually some notes here. Okay, so this is something you're going to write down. This is for when we want to solve something. I just put this big marking here because usually they use an x, but really it might not just be x. Instead of just x, maybe it's something like this, 4x plus 1. It could be any type of expression. So this little block here is an expression. So you're going to watch that. When m or n is even, primarily it's this one right here that you need to worry about being even. Okay? You really want to watch out for that m. When you have something raised to a rational exponent and you're solving for x, x is going to be in here somewhere. You need to get rid of this power to get x alone. So you're going to raise both sides to the reciprocal power. Okay? Reciprocal. Why is that helpful? The reason that's going to be helpful is when you multiply reciprocals, you get 1, so nothing will be left there. And you'll just be able to play around and evaluate this right there. The inside will be left alone, similar to when we get the radicand left alone up there. Okay, so when this is even, we got to watch out. We have to set up with this plus or minus. So you raise both sides to the reciprocal power. The expression is left alone. Plus minus, whatever that is, to the n over m. Evaluate it, clean it up. Or you could look at it as the absolute value of this equals that, but that would still split into a positive and a negative. Now, pause the video, take some time, copy this down, or maybe follow the next couple of examples and come back and then write this down in your own words. But you definitely need some sort of a note on this, and I will elaborate on this when we have some examples in front of us. But essentially it has to do with this. Ready? If that is even, if you raise both sides to this power, that means you are taking an even root of both sides. If you take an even root of something, you need to have accounted for all answers, so you need the plus minus. So that is where all this stems from. Okay? So we're going to see that in this example. We're going to start right over here. What is the solution of this problem? We're going to isolate the radical. This is essentially the radical, the expression with the rational exponent. So I'm going to divide both sides by 3. I get a 4 over here, and I have x plus 1 to the 2/3. Now, I need to raise both sides to the 3 over 2. That's even. That means you're raising it to the 3rd power and taking the square root. That means we need a plus minus. These 3's cross out, those 2's cross out. This reduces to 1. We have an x plus 1 equals plus minus. Swappertunity. I'm going to use 2 squared to the 3 over 2. Squared, and this 2 gives me 2 to the 3rd power. So, plus minus 2 to the 3rd, which equals plus minus 8. And then we just finish from there, a little bit left. X plus 1 equals 8, which gives me x equals 7, and x plus 1 equals negative 8, which means x equals negative 9. Done. Okay? Here we have another example. Same idea. This is really 3/5 power. See how it's really a radical. We want to isolate this. You need to get rid of the plus 1 first, not the 3. Always undo your addition or subtraction first. So if I subtract 1, I get a 24. Then I'm going to divide by 3. That's going to give me an 8 over here. What equals 8? This is really, I'm going to rewrite it as x plus 1 to the 3/5 power. Now, I'm going to raise both sides to the reciprocal power. What would that be? 5/3. I don't have an even power. No even powers, so there's really nothing to worry about. They just cross out, no even roots. X plus 1 equals, I'm going to do this opportunity, 8 is 2 to the 3rd to the 5/3. 3's cross out, 2 to the 5th, which is 32. And here's x plus 1. So, final answer, x equals 31. And we're done. That's the end of it. Next example. What are the solutions of this problem? So you want to watch if they're asking for plural or singular. Maybe that's a hint. I'm going to divide both sides by 2. Isolate the radical. This over here is the radical, okay? Divide by 2 and we get x plus 3 to the 2/3 equals 8 divided by 2 is 4. But I could even right away replace 4 with 2 to the 2nd power. Raise both sides to the reciprocal power, which is 3 over 2. There's that even number right there. 3 over 2. Those 2's cross out. That means, right there, that I need that plus minus. These all cross out. X plus 3 equals plus and minus 8. Solve each one. X plus 3 equals 8, which means x equals 5. And x plus 3 is negative 8, which means x equals negative 11. And we're done. That's the end of it. Alright, in this next example, the directions are going to start to ask us to check our answers. Basically, if you have an x that's not inside of your radical, this free little x, he's running wild, he's not inside the square root, he's not held captive over there, this is where we have to worry about extraneous solutions. Okay, so whenever your problem has this loose x running around, we have to worry about extraneous. Okay? So we're still going to solve it the same way. We're going to isolate the radical. So we're going to start off by adding 5 to both sides. So x plus 1 under the square root, or if you want to rewrite it as to the 1/2 power, you can do that, is equal to x plus 5. Now, how do you get rid of a square root? Well, actually, what if you think of it as 1/2 power? So we could connect it to those other examples a little bit more. What do I have to do here? Raise both sides to the 2/1 power. Isn't that the same as squaring? 1/2 and 2/1 are gone. I don't need plus minus, okay? You don't need a plus minus right here. So you have x plus 1 alone equals, this is not that. Okay, do not do that. That is bad. You have to expand this, so x squared plus 10x plus 25. That's good. It's a polynomial. We're going to solve by getting it equal to 0. X squared plus 9x plus 24. What multiplies to give us 24 and adds or subtracts? Ooh, it's blurry. There we go. X plus 1, 9, 24, 12, 2, 8 and 3, no. 6 and 4, no. So I just noticed a mistake. This was supposed to be an x plus 7. Okay, oops, sorry. And if that's a 7, that's a 7, that's a 7. If I bring over 7 from 25, that makes this an 18. Okay, so it changes things a bit. That's going to be x plus 3, x plus 6, and then we solve this with the 0 product property. That's going to be x plus 3 equals 0, so x equals -3, and x plus 6 equals 0, so x equals -6. But check your answers. We plug those back in. -3 plus 7 is 4. Square root of 4 is 2. 2 minus 5 is -3. That works. -6 plus 7 is 1. Square root of 1 is 1. 1 minus 5 is -4. Does not work. So this one is extraneous. Okay? This one is good. So we only had one answer work. Let's see another one. Here, same idea. We're going to solve and check. So we're going to subtract 3. Square root of 5x minus 1 equals x minus 3. 5x minus 1 equals, we're squaring both sides. That'll be x squared minus 6x plus 9. 0 equals x squared minus 11x plus 10. Factor x10, x1 minus minus x equals 10, x equals 1. Check them. 50 minus 1 is 49. Square root of 49 is 7. 7 plus 3 is 10. 1. 5 times 1 is 5. Minus 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. Doesn't work. Sometimes both answers will be extraneous. Sometimes neither answer will be extraneous. And sometimes just one. So you cannot jump to any conclusions. Alright? Up here, down here. So when should you check for extraneous solutions? Basically, when you have an x, or any other variable for that matter, outside of the radical. That's a good rule of thumb. When you have an x outside of the radical. Alright, here, a little different. We have two radicals. What you want to do is, I like to take one of the radicals to the other side, even if it's with another number. So I'm going to get here a 2x plus 1 equals 1 plus the square root of x. If I square both sides, you're going to have to expand this the way you would using FOIL. This will be a 2x plus 1 only. This 1, we're going to do this, 1 plus rad x plus rad x plus rad x. So it's 2 rad x plus square root of x, so square root of x is just x. I'm going to subtract 1, subtract x. So that gives me x alone, the ones are basically gone, equals 2 square root x. We have to square both sides again. That gives us an x squared equals, you got to square the 2 and the rad x. That's 4x. Okay, now running out of room, so scooting around over here. Do not divide by x. Do not divide by x. Do not divide by x. Okay, it's still a polynomial. You have to get it equal to 0. So x squared minus 4x is 0. Factor out the x. Still use 0 product property. If you want to check for extraneous, you can. That'll be square root of 1 minus 0. So that works. Plug in 4. That's square root of 9, which is 3. Minus square root of 4, which is 2. 3 minus 2 is 1. They both work. Really didn't need to, but checked anyway. Okay. Last example. Same thing. Bring this to the other side. Square root of 5x plus 4 equals 4 plus square root x. Square both sides. 5x plus 4 equals 4 times 4, 16. 4 rad x plus 4 rad x is 8 rad x, and then square root of x times square root of x is x. Subtract x, I get 4x. Subtract 16, I get minus 12, equals 8 square root x. I could even divide everyone by 4. You could divide by a constant. You don't want to divide by a variable. What does this give me? X minus 3 equals 2 square root x. We have to square both sides. Again, we still have a radical. X squared minus 6x plus 9 equals 4x. From there, get it equal to 0. X squared minus 10x plus 9 is 0. X minus 9, x minus 1. If you fill them in to check, 45 plus 4 is 49. Square root of 49 is 7. 7 minus the square root of 9 is 7 minus 3. That works. Fill in the 1. Square root of 9 is 3. 5 times 1 plus 4, yeah. Square root of 9 is 3. 3 minus 1 is 2. So that one does not work. Okay? So we gotta watch out. We only had one answer in this case, so I hope you kind of have the hang of it.